A multi-driven net is a net that is driven by more than one source. For example, an output of two or more gates connected to the same net, or a net that is driven by both combinational and sequential cells. And multi-driven nets can be created in various ways during design. These include assigning the same signal or net to multiple nets in the RTL design, improper use of tri-state buffers and shared buses, and combining output signals from multiple modules without proper arbitration. The creation or presence of multi-driven nets in the design impacts power, performance, and area. Multi-driven nets can make the final logic value unpredictable, leading to bugs in silicon. During synthesis, multi-driven nets may be generated, which can stop the process, cause errors, and produce an incorrect netlist. These nets can create short circuits, increasing power consumption and leakage. They also affect the timing due to undefined transitions. To fix multi-driven nets, additional logic like buffers must be added, which increases the design's area. There are various ways to identify multi-driven nets in the design once they are created. These include warnings generated during the synthesis stage, using linter tools, analyzing reports produced at different stages of the flow to debug unintentional net creation, and examining simulation runs of pre- and post-root netlists. There are several approaches to prevent the creation of multi-driven nets in the design. These include following RTL coding discipline, where one data signal is assigned to a single always block. A proper enable signal must be used for tri-state buffers or multiplexers. Minimize conflicts between modules when declaring and assigning nets for each module. Use attributes correctly in synthesis and implementation tools to guide the flow without causing conflicts or issues. Here are some of the RTL code examples of multi-driven nets. The first example shows that two nets A and B are assigned to same net Y. This will create a multi-driven net in the design. To avoid this, it is good to create a register with an enable signal named select and store the A and B variables in the same net, not at the same time. The second example is having an issue with two always blocks to store two different variables in the same register, which means two always blocks are driving the same register. This may cause undefined behavior. To resolve the problem of multiple always blocks driving the same register, we can use a single always block with a conditional statement. When multi-driven nets need to be created, in the design with tri-state buses, where multiple modules share a common bus and one driver is using the enable signal at a time to drive it, and in the communication protocol designs using open drain and wired end logics, how to avoid the creation of multi-driven nets by not assigning the single net to multiple nets in the combinational logic, avoiding use of multiple always block in sequential logic, and not driving the same net from one hierarchy to another.